I am Dr. R.K. Narayanan, Assistant Professor, Department of Chemistry, SNH, SNS College of Engineering, Coimbatore. Now I am going to discuss about applied chemistry, especially in the electrochemistry part. In this electrochemistry, I am going to discuss about the electrosensors. What is the electrosensors? What is sensor? We already discussed in the previous videos that explained about some physical movement or monitoring their light or sound or whatever the real-time data collections based on the things we are using sensors. Okay, where the electro sensors are useful: medical diagnosis, environmental monitoring, and allowing real-time time data collection. Okay, and especially automation, and a lot of industrial fields are highly is involved in the electro sensors. So here we are going to see about types of electrosensors. What are the types? One is voltage sensors, current sensor, capacitive sensors, and resistive sensor, inductive sensors. Okay, these all the sensors are related to the electrosensors. Okay, we know about voltage, how much voltage is passed through the cable. Okay, if you take the some wire or iron rod or iron cable, there is some electron transfer with there. How much voltage is passing in the wire? Okay, we can calculate with sensor voltage sensors based on the uh, monitoring the system with the controlling the electrical systems. We can conclude the voltage sensors. Another one is current sensors. These sensors detect electrical current, that is especially the flow of current, and it's especially for environment and power management systems. It's a highly efficiency. And capacitive sensors. Okay, these sensors detect capacitance change, how the capacitance is useful if it is a touch screen, and proximity sensing, how much it's applicable for the electrosense. Another resistance, how much resistance is protect. If it is more or high, some fixed value we can make it with the help of sensor. We can finalize and we can calculate which level it's applicable. We could find the resistive sensors. Another is inductive sensors, like similar concepts. Another is application of electro sensors field. It's wide applications, but we are discussing about some industrial automation, medical diagnostics, and environmental monitoring systems, and consumer electronics. Another one is automotive industries. Okay, we know about consumer electronics. What are the consumer electronics? Simple concept. Take it our mobile. Okay, how the touch screen is working. So that is sensors. And industrial automation, we know about. At present, we are facing a lot of problem, especially for human needs. Okay, for all the field, but the lack of humans and that workers, we are using automation sensor for the accuracy of the manufacturing purposes and reducing the cost effect. And medical diagnosis, medical invasive monitoring, vital load. We know about the how the signs are better patient taking care in the care per minute. How if it is there any sensors, there is blood pressure or sugar, and these all the things will come into the medical field. Environmental monitoring, we know about temperature and humidity, and that poisonous gas, nitrogen and carbon dioxide, carbon monoxide. These are highly useful to identify. Another one is automotive sensors. Automotive sensors, we know about, just think about our two-wheeler vehicles, just that side stands. It's working with the electrical sensor concepts. If you are not removing the side stand, automatically what will happen, the vehicle will not get started. So what is the working principle? Ohm's law. It's related to the voltage, current, and resistance. These are the fundamental system to find the accuracy of measurements. And capacitance changes, capacitive sensor, to detect the changes in the capacitance, how much the current flow and all the things are it's applicable. Proximity is particular condition. And inductive coupling sensor and inductive sensors generate an electromagnetic field that help to detect the conductivity material and that will support to enabling the conduct of that sensors, especially for find out the sensing applications. And thermal effect, thermal is how it's going to affect the if it is high temperature or low temperature. So these are the concept will majorly involve in the Prince electrosensor and signal processing. How we are using, how we are processing the signals, whether how much data we are taking from the sensors. So these are the things will play a major role. And benefits of electrosensors, we know the high sensitivity, we can find the small electrical changes in the high sensitivity. Real time monitoring, data collection is quick response changes, the crucial changes. Safety, all the aspect with highly efficiency way. And versatility, electrosensor used lot of field in the industry, especially healthcare and technology development. And cost effective comparative, if you are using 10 members of 10 human people, you can use as a one sensor, it will find the result with a great way. That future trends related to always would be AAN and IoT and miniaturization and smart sensors, enhanced connectivity, energy harvesting. These all the fields are highly important. And challenges, calibration issue and environmental factors common, but data overload problems. So these are the problems. So vital components and driving innovation and addressing challenges, overcoming the obstacles will be the crucial maximizing the which one that sensors potential and how we are going to the reliability of future developments. Thank you.